All right, welcome back. Today I'm going to be going over the solution problems for your percentage yield / limiting reactant worksheet. Pretty much your last assignment for Chapter 9 stoichiometry. So theoretical yield and percent yield and actual yield, they're all connected together by the equation percent yield equals actual divided by theoretical times 100. So when they're asking what's the percent yield, like the reason why it's in a percentage is because you're multiplying by 100 and the units are going to cancel out. So I'll just write the equation off to the side here. So percent yield is your actual divided by your theoretical times 100. Okay. So your theoretical yield is 50 grams and your actual yield is 41.98. So you're going to take your actual 41.98 grams divided by your theoretical times 100 to get your percent yield. So you punch this into a calculator, 41.9 divided by 50 times 100. I get 83.8%. That's my percent yield. That's it. That's all I got to do. Theoretical yield is 290 kilograms of a product. Actual yield is 270. Again, you take your actual divided by your theoretical. 270 kilograms divided by 290 kilograms times 100. So you punch this in your calculator, you get around 93.1%. Pretty simple stuff here. Moving on. In the commercial production of arsenic oxide is heated with carbon, reduces the oxide to the metal according to the following equation. If I have 8.87 grams of arsenic oxide used in the reaction and 5.33 grams of arsenic is produced, what's the percent yield? Now this one, we're going to take it up a step. I'm going to start with my As2O3, okay? And I'm going to go to AS. What they gave me was my actual, okay? This is my actual. When you use your limiting reactant, in this case, whatever they give you, it should give you your theoretical. So in theory, this is what you should actually get, okay, out of this reaction. But we know that chemistry is not always perfect. You usually get a little bit less than what you're supposed to get. So I'm going to start with what I'm given, 8.87 grams of As2O3, and I have to get to arsenic. Now I'm in grams of As2O3, which means I need to convert to moles, because using the mole ratio is the only way I can convert from one substance to another substance. So I've got to figure out the molar mass of As2O3. So arsenic, I have two of them, each at 74.92, and oxygen, 3 at 15.99, and I add them all up together, 197.81 grams. So if I measured out 197.81 grams of As2O3, I would have a mole of As2O3. So I'm in grams, so grams is going to go on the bottom. This is going to go there. So 197.81 grams of As2O3 is equivalent to 1 mole of As2O3. Okay, now I'm in moles, and I can use the mole ratio. I'm going from As2O3 to As. So I'm in moles of As2O3. That's going to go on the bottom, but I'm going to put a 2 here. 2 moles of As2O3 to 4 moles of arsenic. Oh. All right. Now I'm in moles of arsenic, and I got to convert from moles to grams by multiplying by the molar mass. So 1 mole of arsenic is equivalent to 74.92. All right, so now I can finally punch this into my calculator. 8.87 times 1 divided by 197.81 times 4 divided by 2 times 74.92 gives me 6.72 grams of arsenic. Now, this is my theoretical. Okay? They want to know what's the percent yield. Well, percent yield is actual divided by theoretical times 100. So my actual was 5.33 grams. My theoretical is 6.72 grams, and then I'm going to multiply that by 100, and I get around 79.3%. There. Let's take a look at another, same chemical equation, just looking at a different reactant. If 67 grams of carbon is used up in a different reaction and 425 grams of arsenic is produced, calculate the percent yield. Okay, so I'm still looking at how much arsenic I can get. This 425 grams is my actual. And you have to start with grams of carbon, and I got to get to arsenic. So I have 67 grams of carbon, but I got to convert grams of carbon to moles of carbon so I can use the mole ratio. Molar mass of carbon on the periodic table is 12.01 grams. I set up the mole ratio. Here's carbon. I'm in moles of carbon, so it's going to be 3 moles of carbon down here so it can cancel out. And I'm trying to get to moles of arsenic, so it'll be 4 moles of arsenic up here. And then, to get for moles of arsenic, I multiply by the molar mass of arsenic. So I put 1 mole of arsenic is equivalent to, and 74.92 grams. All right, punch this in. 67 times 1 divided by 12.01 times 4 divided by 3 times 74.92 divided by 1 equals, big number, 557.3 grams of AS. Now this is my theoretical. I should get 557.3 grams, but I only got 425. So what's my percent yield? So I'm going to take my actual divided by my theoretical times 100, right? So my actual was 425 grams divided by my theoretical, 557.3 grams times 100, and I get 76.3%. Okay, just making sure. There we go. Those are the solutions. I feel like this is a little bit easier, but again, let me know if you guys have questions, comments, or concerns.